Hi everyone, in this video I'm going to talk about fractional exponents. So right now here's the general form how we write from a fraction, which is m over n, to radical form. So these represent the same expressions, but one is in fractional form and one is in radical form. So take a look to see how we write it. If I have some number or some variable raised to a fraction, m over n, the denominator here is the root. So inside this little V shape here, which is also called the index, so this is also called the index, that will determine your root. And then you will be raising it to this exponent here, m. So you can write it in two ways. You can either write it the way that they wrote it here, or you can write it in this sense. All right, so before we understand fractional exponents, it's important to understand perfect squares, perfect cubes, perfect fourths, and fifths, and so on. So let's go ahead and take a look at that. We all know that a perfect square is a number times itself. So for example, 4 is a perfect square since 2 times 2 is 4. And of course, we can also write it as 2 squared. 9 is a perfect square since 3 times 3 is 9. And we can write that as 3 squared. And 16 is a perfect square since 4 times 4 is 16. And we can write that as 4 squared. And I can go on and on and on. Now, what is the opposite of squaring? The opposite of squaring is square rooting. So if you look down this list, here is our perfect squares. Okay, so 1 is a perfect square, 4, 9, 16, 25, 36, and so on. So I have all these listed here. These are my perfect squares. So if I square 1, I will get 1. The opposite of squaring is taking the square root. So if I take the square root of 1, of course we still have 1. But as you go down the list here, you can see that 3 squared, for example, is 9. And the opposite of squaring is square rooting. So if I go backwards, take the square root of 9, we get 3. Okay, so this is with perfect squares. Let's go ahead and look at perfect cube. A perfect cube is a number times itself 3 times. So for example, 8 is a perfect cube since I can write it as 2 times 2 times 2, which is equivalent to 2 cubed. And 27 is a perfect cube because we can write it as 3 times 3 times 3, or 3 cubed. And 64 is a perfect cube since we can write it as 4 times 4 times 4, which is 64, and so on. Now, the same way we can find the opposite of squaring, we can find the opposite of cubing. So if you take a look here, and we can go on with all the numbers, I have all my perfect cubes listed here. Okay, and I obtained those by cubing 1, by cubing 2, by cubing 3, and so on. Now, if I want to go backwards and find the cube root, then here's the symbol for the cube root. So the cube root of 1 is 1, and the cube root of 8 is 2, and the cube root of 27 is 3. Now, pay attention to the notation here. I have the cube root of 8. This here, what I mentioned before, is the index. And so if I want to take the cube root of 8, this is how I know to take the cube root. It's by the number that's inside this little radical. All right, so now let's take a look at perfect fourths. A perfect fourth is a number multiplied by itself 4 times. So we can go on and say 16 is a perfect fourth since 2 times 2 times 2 times 2 is 16. And of course, we can write that as 2 to the 4th. If you notice, 16 is also a perfect square because we can write it as 4 times 4, which is 4 squared. And 81 is a perfect fourth, since 3 times 3 times 3 times 3 is 81. But it also is a perfect square because we can write it as 9 times 9, which is 9 squared. So we can go on with an infinite amount of examples, but I just showed 16 and 81 as perfect fourths. Now, the opposite of raising a number to the fourth power is taking the fourth root. Notice the index here is now 4. This indicates that you are taking the fourth root. So if you look at the perfect fourth, for example, 81, 81 is the same as 3 to the fourth, or in other words, 3 times 3 times 3 times 3. So that would be a number times itself 4 times. Well, the opposite of that is taking the fourth root. So you can see right here with my index, the fourth root of 81 is 3. All right, let's look at the last one, perfect fifths. A perfect fifth is a number multiplied by itself 5 times. And for example, 32 is a perfect fifth because I can write it as 2 times 2 times 2 times 2 times 2, which is equivalent to 2 to the fifth. So 2 to the fifth is 32. And we can do the same thing with 3. If I multiply 3 by itself 5 times, we will get 243. So 3 to the fifth is equivalent to 243. So we can say that 243 is a perfect fifth. Now let's take a look at the index this time. It shows a 5. So this shows me that we are taking the fifth root. So the fifth root is written inside the little v of your radical. Okay, and you have to look to see what this number is to determine what type of root we are taking. So just for your information, if you see the number such as with no index written here, by default, that is a 2. So normally we do not write a 2, otherwise we know it as square root. The square root of 16, we can write it without the 2. And this is what you are probably used to working with in the past. But now we're introducing new roots. So any other number but 2 has to be written in so that you will know which root to take. All right, and so you can see the perfect fifths, how we got them, and the opposite is taking the fifth root. Now here is a list of all perfect squares, cubes, fourths, and fifths. And of course, it's just a chart. You can always multiply it out. You can see these here are all perfect squares. All these numbers here are perfect squares because they can be written as a number times itself. All these numbers here are perfect cubes because they can be written as a number times itself 3 times. And so this x right here represents whatever value we plug in. All right. So let's go ahead and do an example now with a fractional exponent. So now that we understand more what the type of roots can be, let's look at an example. All right, so one type of example is going from rewriting an expression from radical form to exponential form. Now you know it's in radical form when you can see the radical. So here's my radical right here, okay? And this time I could see it is the fourth root of x. How do I write that as an exponent? Well, what exponent does x have? We know if we don't see an exponent, that means it has a 1. Otherwise, it would be written in. So this is equivalent to writing it in fractional notation. I would write it as 1 over 4. Remember, the root is always your denominator. So pay attention here. My denominator is the root. In this case, that is my index, which is indicated here as 4. So be careful. Always put the root in the denominator when you're writing it as a fraction. All right, now we're going to do the opposite. We're going to go from fractional notation to radical. So the first thing I'm going to do is I'm going to write a radical symbol. I'm going to put my x inside. And now the question is, what is my root? So do you recall what I said here? The root is always in the denominator. So the denominator is 5. So I'm going to put a little 5 here. Now don't put it too large. You want to put it inside your little radical. And if you remember, we can write this in two ways. One way is this means take the fifth root of x and then cube it, okay? Or you can write this as, take the fifth root of x, but first you're going to cube the x. So this means cube the x first, take the fifth root of that. The order in which you do it doesn't really matter. You will end up with the same answer. So let's go ahead and look at an example. All right, how will we evaluate 32 to the 2/5? Well, if you remember, the denominator indicates the root. So if it's easier, you can switch this to radical form, or you can work directly from this number. So this is telling me to take the fifth root of 32 and then square it. Or I can square 32, then take the fifth root. But it's much easier to shrink your number first than make it really large. So what I'm going to do first, and I'm going to rewrite this in radical form. So radical form, I will put the 32 in my radical, and this is telling me to take the fifth root. So actually, the way this is typed up, the 2/5 looks really large. If I had to rewrite this, I would write the 2/5 much smaller as an exponent. So exponents are usually written really tiny, and this is a little bit confusing because it's large. So this is the better way to write your exponent because this is kind of large. But it's the same idea. The 5 here is your root, so I'm going to put that there. And then I'm going to raise this all to the second power. So if you recall from the previous slides, the way to think about it is, how do I find the fifth root of 32? Well, finding the fifth root of 32 is like asking what number times itself will give me 32, and I want one of those numbers. So if you recall from the last slides, we said that 2 to the 5th is 32. So going backwards, because the opposite of raising a number to the 5th power is taking the 5th root. So the 5th root of 32 would be 2. So the 5th root of 32, I could just replace that with the number 2, and then I will square it, because the next step would be to square. So 2 squared is 4. So 32 to the 2/5 is equivalent to the number 4. So this means that it is the number 4. So 32 to the 2/5 is 4. Let's try one last one. If you want to pause the video here and try this on your own, then go ahead and do so. So I'm going to rewrite this with a much smaller fraction, because this is a fractional exponent. This is telling us to take the fourth root of 16 and then cube it, or if you prefer, take 16, cube it, and then take the fourth root. So as I mentioned before, it's a lot easier to take the fourth root. In other words, shrink your number first. So this is equivalent to writing it as 16 with my fourth root in here, and then I'm going to take this number and cube it. So what is the fourth root of 16? Can you think of a number when you multiply it by itself 4 times by itself, it gives you 16? So if you said 2 times 2 times 2 times 2 is 16, you are right. See, here's my number multiplied by itself 4 times. So that's the fourth root of 16 is one of these. So it is 2. So I'm going to replace this by 2, and then I'm going to cube it. What is 2 cubed? Well, it is just 2 times 2 times 2, which is 8. So evaluating 16 to the 3/4, that is 8.